Okay, so today we're going to cover chapter 6. It focuses mainly on files and how to deal with exceptions that files may cause during your program execution. And so a couple of things you guys are already familiar with, but a couple of the things are new, and specifically they exist only in Python. So we're going to look through those. Okay, file, input, and output. So these are pretty simple. I mean, we already know this thing. So we can either open a file, or we open the file for writing some data to it, or we can open a file to read some data from it. So usually all of the data is going to be saved to a file when you're working with it. The larger your programs are going to be, the larger the input you're going to get from your users, the more information you will have to store inside of those files. And writing data to, if you're going to hear that term, and you're going to hear it pretty often, that just means that you're going to save some data to a file. So basically, when you hear writing data to a file, that just means you're going to save whatever information you're working with. It's going to be saved outside of your program to an external file. Now, output file, it's just a term for a file where we're writing our data to. And then input file is a file that we're going to read data from. And it's the same idea as writing to a file. The term is reading data from a file, that you're just going to retrieve some sort of data and you're going to work with it inside of your program. There are 3 steps usually. Again, this is just a recap. There are 3 steps whenever your program is going to use a file. It's going to open it, it's going to do something to the file, and then it's going to close the file. While opening and closing the file are 2 things that are necessary, you do not have to do anything with the file inside of your program. It is not a necessary step. However, most of the times, if you're opening the file, obviously you're going to do something with it. But very important part, that you have to close a file after you have worked with it or after you opened it, because if you do not, the program is going to throw an error, and it's just not good overall. So every time you open the file, you have to close the file. Now, there are 2 types of files that we generally see. Is either a text file, just, your normal notepad file, or anything that you have on your notes app on your phone. That's a text file. And then there is a binary file, and that is just data that has not been converted to text. So anything that is not a text file, usually it is a binary file. Now, 2 ways to access data. Again, this is just a quick recap. There's sequential access, and sequential, it's literally in the name. You're going to sequentially access whatever contents of your file is from the beginning to the end. You cannot skip, you cannot pick one item out of that file. If you have a file that is accessed in a sequential way, it's going to go from the very beginning of your file up until the very end of your file. So every content of your file is going to be sequentially accessed. Now, direct access, also pretty simple. It's in the name. You can directly access any piece of information, any piece of data that file has. So you can directly jump into whatever part of your file you want and access whatever information you want to get from that file. Now, file name extensions, those are just whatever comes after the period. You are pretty familiar with those. So kind of like txt. Txt is an extension. Same thing with the JPEG, .jpeg for pictures. JPEG. Those are all file extensions. They just specify whatever data is stored inside of that file. So if you see .txt, you know that text is stored in that file. If you see .jpeg, that means that it is a picture. If you see .mov, that is usually a video. And the same thing is like .mp3, that was an old way of storing audio files, music. So that probably like as a song or something like that, if you see .mp3. So those just specify what exactly is stored within that file. Now, file object is just something that lets us as coders work with the files inside of our program. So usually if you want to open a file, or you want to work with some sort of file, you will have to create a file object and then use those objects functions to work with the file directly. And I will show you examples of that later. So there is a way to work with files, obviously, in Python. And there's a couple of embedded functions, a couple of library functions that you need to know. First one is open. So whenever you want to open a file, this is the way you would have to do it. So you will have to create a variable with the name that goes with the file. So something along the lines of what the file contains or how you want to name the file. So it's going to be a name, whatever you want it to be. Then you're going to put an equal sign, and then you will use the keyword open. So you're going to use the keyword open your parentheses, and put whatever file you want to open. It's going to be right here under the file name. You'll put whatever file you want to open. You will put a comma, and then after that, you will specify with which mode you want to open that file. And there are only 3 modes in Python. They are also pretty easy to remember. So the first one is R, stands for reading only. So you're not going to change anything inside of that file. You will only work with its contents. Now, the next one is writing, W. So that is whenever you want to create a new file, whenever you want to store your data somewhere in the file, this is what you're going to use. You're going to use the writing mode. And appending it works the same way as writing. However, with appending, it's a little bit different, because writing, if you use your mode as writing, the file will be overwritten. Even if it exists already in your system, if you open a file for writing, it's going to be completely overwritten, and the contents of the file that were there before, previously, they're going to be fully deleted. Now, appending prevents that. Appending will just add your data on top of what already exists, if that file exists. And we'll go a little bit more into details about that later. So you can also specify the location of where that file exists inside of the open function. However, if you use your open function by default, it's just gonna assume that your file exists in the same folder where your program is stored. So basically, directory, folder, doesn't really matter. It just assumes that the location of that file is the same as the location of your program, which is calling that open function to open the file. Now, if you are creating a new file, such as with the writing function, if you're creating a new file, that file will be created in the same folder where your program is stored. All right, now focusing more on each of the modes. So whenever you write data to a file, this is how you will do it. So you will use that file variable that you created, that file object, right? Whenever you opened your file, you assigned that file to a certain variable name. So this is the variable, the same variable name that you are going to use. And then you're just going to put dot write. So that will specify that you want to write something to a file. And then inside of the parentheses, you can put a string, you can put a sentence, a word, doesn't really matter, a text. So whatever you want to write to a file is going to be inside of the parentheses. Whenever you're done working with that file, you have to close it. And this is the way you do it. So you will put that same name that you used to store your file with a dot close. Those are the keywords, close, right? Those are all the keywords. So this with empty parentheses, this sentence right here, the close one, will just simply close your object and let your program know that this file does not need to be worked with any longer. All right, moving on, reading data. Reading is pretty simple. Let me show you an actual example of reading. Oh, never mind, it's going to be way later. Okay, so whenever we read something from a file, you do not change any contents of your file. You simply take that data and move it, create a copy of it and move it to your program. Now, nothing in that file that you're reading ever is going to be changed if you open it just for reading. So do not worry about the contents of it. Do not worry about messing it up. So it's a great way to start working with files. If you're afraid you're going to mess something up, just open it for read method, and that way you know that your file will never be changed. all of the contents that you read from a file are going to be returned as string. So even if it's integers or decimals or floats, doesn't really matter. They're all going to be returned as strings. And you, as a coder, you will have to make sure that those values are converted into their specified data types. So it's integers, decimals, floats. You will have to make sure that those are converted somewhere in the execution of your program if you want them to be converted, that is, obviously. Now, readline method. Readline is just something that a way for us to work with files again and read data from it. However, readline will read a whole line from the file. Literally, it's in the name, so nothing too complicated. You have a line of text. That whole line is going to be read as one piece of information, one piece of data, with the usage of the readline method. Concatenating new lines. Okay, we don't need to focus on that. All right, appending data, the next and the last mode that we're going to cover. So appending data, kind of explained it already. If the file exists and you use an append data mode on that file, it is not going to be erased. It will just add more data to the already existing file. So it works the same way as write. The only difference is that the write mode will completely overwrite your file if it already exists, and the append mode will not do that. The append mode will just add data to already existing file. As I mentioned before, since everything that you read is a string from the files, even though if it's numbers, it's still going to be a string. That same idea works for putting data into files. So everything that is going into the files has to be converted to string. Even if you have numbers, even if you have any Boolean values, all of those have to be converted to string before they can go into the file. And you can do that by using the str function. The format is pretty simple. You just put str, you open your parentheses, and then you put whatever value you want to be converted to string. So the same way as whenever we read input, we wanted to convert that input to integers, we would have to put int in front of the input function. The same idea works here. You have to put str before you write any data to a file. All right, let's see. Usually you will use a loop whenever you're working with the files and you want to read a large chunk of data. You will have to use a loop. And let me show you a couple of examples that exist already in Python. So Python is a great programming language because it has these built-in loops that are already automatically going to read all of the lines in the file for you. So the format is, it's a for loop. The format is for each line that exists in whatever file you want to open, do something. So in this case, the only keywords here are for and in. So those keywords have to stay in each of the loops that you write. However, line is an optional word, and file object is also an optional word because you can specify whatever names you want for these two, for line and for file object. Let's go back and let me show you what it looks like. So whenever you use a loop, this is how usually the logic behind it works. So you're going to open your file. The first thing that you're going to do, open your file. Then you're going to use read line to read the first line from the file, right? The read line that reads the whole line as a whole. Now, did read line return an empty string? Because if the read line will return an empty string to us, that just means we reached the end of the file and there's nothing else available for us to read. So we're going to ask a question. Did readline return an empty string? If it didn't, then we're going to process whatever readline returned because it's not an empty string. Then we're going to use the readline again to read the next line from the file. And then we're going to go back all the way to asking our question again. Did readline return an empty string? So this is just going to loop all the way until the end of your file. Then if your readline will return an empty string, then that would just specify that we reached the end of the file and we're going to close the file at the end. Okay, let's see. You can also, there's a with statement that exists in Python. This is something new, something that you've never seen before, but with just lets you open and close a file automatically. So you do not have to close the file at the very end of your program. If you're using with, that way, when your file is open, it will automatically be closed, and you do not have to exclusively state that you want to close the file. And this is the format. So you're gonna with the keyword with, the keyword open, then you're gonna open your parentheses, specify which file you want to open, then with which mode, R, W, or A, which stands for reading, writing, or append. And then you're gonna specify, you're gonna put a keyword as, and you will specify the file variable name. So in which file variable you want to store your file. And then you're gonna put a colon and then whatever you want to be performed inside. So pretty simple, nothing too complicated. Let's see, this is an example of opening myfile.txt for writing. So as you can see, we put with, open myfile.txt with a comma and W. So that specifies that we opened it for writing as output file. This word right here is not a keyword. This was specified by the programmer. So you as a coder, you can specify whatever name you want for this file. And then something happened to that file inside of that with statement. This is the way to open that same file for reading. As you can see with open myfile.txt, R as input file. So again, it's the same idea, just the only difference is between W and R. And you can also open multiple files with that with statement. So as you can see, all you have to do is just put a comma between the files that you want to open. So we opened file 1.txt for reading, and then we also opened file 2.txt for writing. It's also possible. So that's a cool thing about Python. You can open as many files as you want on the same line, basically, inside of the same statement. Now see, there's also such thing as records, and those you will see a lot of those whenever you move to your SQL course, SQL course, which is, I think is the next one that you guys have. And those are just basically think of it as a some sort of data that describes one item. So basically, I will gonna show you a picture right here. Oh, maybe not. I do not have a picture. I apologize. So records are, just think of them as a line that has all of the information about some sort of item, right? So this record will be divided into fields, and each field will have some sort of information about an item. For example, let's say we have a record about an employee, right? Employee at some company, at some firm. So the first field will be, for example, their name, their full name, last name, middle name, first name. Then the second will be their social security number. Then the third will be their phone number. The fourth one will be the department where they work in, and for example, their salary and whatever, their date of birth. So this way, this whole thing, the whole piece of information about the employee will be called a record. And then each one of the attributes, so each one of the fields, those are called fields for your record. There's also, whenever you're working with those records, you have to be mindful of a couple of things. So your program has to be able to add records, then display records, also display any specific field that you want to access, then search for a specific record. So search, for example, you have 300 employees in your company. You want to be able to search for a specific employee, obviously, right? Then you have to be able to modify records. For example, if one employee moves to a different department, you have to be able to change the name of the department that they're working in, because they won't be working in that department anymore, and delete records. Again, with an example of the employee, if somebody gets fired or if somebody quits, you have to be able to go into your database and delete that record. And again, this is all going to be explained more into your SQL classes. This is just a little introduction into what those are, that those things exist. So you do not have to focus on this too much, just a general idea of what records are, what fields are. Now, exceptions, you are also familiar with these from Java. So whenever we work with files, there are usually a couple of common exceptions that can happen. Now, let me show you a couple of those. So there are many exceptions that can also be prevented by you being a careful coder. And those are usually input validation. For example, you are also familiar with input validation. Those are, for example, if you ask your user to enter a name and they give you a number, you know for sure with the usage of input validation, you will know that number is not something that you're looking for. So if your program encounters a number, you will let your user know, no, we asked for a name, please type your name. Do not type a number. Now, some exceptions also you cannot avoid by being a careful coder. And those are, for example, converting strings that do not contain any integers to an integer, or trying to open a file that doesn't exist. And for those, we have a try except block. Now in Java, that is a try catch block. In Python, it's the same idea. The only difference is we're using except keyword, except instead of the catch keyword. And this is the way it works. So you will put your keyword try with a colon, and then whatever you want to do, whatever you want to check inside of that try statement. Then after that, you're going to put except, and you're going to specify the exception name that you're trying to catch. And then you're going to put a colon and write whatever statements you want your program to show you if that exception occurs. So for example, let's see. For example, if you have a error whenever your file is being opened, you can make sure that your compiler lets you know that they struggle with opening a file. So how that's going to happen is you're going to put try, and then inside of this, you're going to try to open a file, right, where the statements are. You're going to try to open your file, and then you're going to put except, and whatever exception name is exists for the fact whenever your file cannot open. Now, after that, in those statements, you're going to print just a simple statement that says, I cannot open the file, or computer cannot open the file. And that way, if your computer cannot open the file or cannot find that file, it's going to let you know that this is exactly what's happening, except instead of just throwing a random error at you. So why would we use exception handlers? Just to let you as a coder know what's actually going on inside of your code. So these are helpful things to know about coding and about working with files. Let's see. Yeah, most of the time you will probably have multiple errors in your code, especially on the first run of your program. So it's going to throw multiple kinds of exceptions. But good thing that for one try block, you can try any exceptions that are in your head. So any exceptions that might happen inside of your program, you can test them. The only difference is that you will have to write the except part of that try except block for each of the exceptions. So as you can see here, this is one except block right here. So you will have to write multiple of these for each exception that exists in your code, or for each exception that can occur in your code. Let's see. Try else. You can also add an else block at the end if there are no exceptions. So if there are no exceptions that occurred, you can put an else block inside of that, and that else block will execute right after your try block stopped executing. So after your try block stopped executing, if there are no errors that were being thrown, if there are no except clauses that got triggered, that else block will execute. If there was an exception in your code, if there was some error in your code, then that else will be skipped. Finally, Yeah, so finally is also another thing that happens that you can put inside of your try except statement. And finally will execute, it doesn't care if the exception occurred or not. So with else, it only occurs if the exception wasn't triggered. Finally doesn't care, finally will execute in any situation. If the exception occurred, if the exception didn't occur, that finally block will execute after your try block stopped executing. If the exception wasn't handled, let's see. Well, okay, if the exception wasn't handled, the only thing you need to know basically is that, well, first of all, you didn't catch that exception, right? And second of all, your code will have an error and your code will let you know that something is going wrong inside of your program. That's the only thing basically you need to know. If your exception is not handled, yeah, your program will just stop executing if the exception is not being handled. Okay, this is all we covered. All right, so that was pretty much it. Let me stop recording real quick.